Hello and welcome to this presentation about what's new in GVERSE Geophysics 2019.3. My name is Hamid Shahid. I'm a product architect for the geophysical tools in the GeoGraphix suite. I've been with the company for about 6 years now, and my main job right now is to try and make sure that our tool and software does what our users want it to do, expect it to do, and that it does that accurately and reliably. A bit more about myself before we start. I have a bachelor's degree in computer systems engineering and a master's in geophysics that I got from Rice University in Houston. I've been with the industry for about 15 years now. I've been involved with seismic data acquisition, where I ran a reporting crew for a number of years. I've done a little bit of processing work and some manipulation work as well. But for the better part of the last 6 years, I've been involved in helping develop tools and software to enable geoscientists to maximize the interpretive value of all kinds of subsurface data. And with the pleasantries out of the way, let's get to today's presentation. The 2019.3 version of GVERSE Geophysics is a big update. It's got a host of new features, and a lot of those features are in areas that geoscientists interpreting seismic data work in pretty much every day. We have a new, very powerful synthetic package that contains all the workflows that you need for creating and editing synthetics, including log code processing, wavelet extraction, and other key workflows built into a sleek new interface. A new fault auto picker that lets you pick faults one at a time or in bulk. We've enhanced our Geobodies workflows to help you get the most out of Geobodies that you pick and create useful outputs to inform other aspects of your overall interpretation. The 2019.3 update also integrates well top editing and picking within the geophysics domain. You can add new picks to a well or just existing ones, all from within GVERSE Geophysics. We are introducing our first AI-driven workflow in the base package as well. It's a self-organizing map-based horizon classification technique that can identify different faces on a horizon and output a map for it. There is a new cross-plotting tool, an update to our line balancing workflows, a new kind of velocity model, and other improvements to depth conversion, powerful new additions to our 3D visualization, and of course many usability enhancements designed to make your workflows more efficient and increase overall productivity. The first of the new additions I want to show you today is the new synthetic module. We've given it a completely new look, made the whole interface much more modern and intuitive. We've tried to keep everything simple and easy so you can create and tie your synthetic quickly. But this upgrade is more than just a facelift. We have added a lot of useful features, and I'm going to show some of those to you now. You can launch this from anywhere you see a well. Just right click on it, say create or edit a synthetic, which opens your input selection dialog. Here you can choose your input logs to create the synthetic and the seismic traces you want to compare your synthetic to as you try and tie your well. SynView, which is what we call our synthetic window, is laid out as tracks. Each track has its own set of display settings that you can access. Here from the ribbon, you can turn these tracks on and off, rearrange them as well. The wavelet used to create the synthetic is given at the bottom left. And here we have the parameters window that gives you the parameters, including your input logs, used to construct the synthetic trace. So these two logs, your sonic and your density, give you this reflectivity series, which is then convolved with this wavelet to get the synthetic trace. So your synthetic is ready, but very rarely can you take just your raw input curves and a generic wavelet to get a meaningful synthetic trace. More often than not, you must correct your logs. You must process your logs. We'll let you do that from right here within the SynView interface. You can block your curves or run a despiking or smoothing algorithm. You may also, for your sonic log, calibrate the sonic with a TD table from a check shot or a VSP that you think is more reliable than your sonic curve. You can also estimate your sonic and your density using the Gardner's equation from within the SynView window. For the wavelet, we give you several analytical wavelets to choose from. You can import wavelets from ASCII files or extract it from seismic data, from a 3D cube, a 2D line, specific section, or in a radius around the well. You can view the wavelet here along with the amplitude and phase response. The wavelet editor lets you view and compare different wavelets. You can also combine different wavelets to create an averaged wavelet from your selected wavelets. We've also made the tying process very interactive. If you want to apply a bulk chip, just click and point. You can just as easily stretch or squeeze your synthetic. The first click anchors the synthetic trace, and the second and third clicks will move the event to where you want it to be. Drift and interval velocity tracks let you keep an eye on the edits you make and to make sure things are not getting too crazy. We have a new multi-point adjustment mode which lets you match multiple events in one go. A correlation window that tells you the correlation between your synthetic and your seismic, and which also computes a time and phase shift that will give the maximum correlation. Once you're done with the edits and you think you have a good tie, save that synthetic to the database. We save everything in the database: the input curves, the wavelet, the edits, and the order you made those edits in, and of course the synthetic itself. So that's our new synthetic module in a nutshell. A great new interface, tons of new capability to help you at every step of the synthetic creation process. The next big feature in 2019.3 is our automatic fault interpretation workflows, which let you auto-pick faults. The way we do this is that you first create what we call a fault volume. This fault volume is basically a few specialized attributes that we combine together into a single volume to help us identify faults in that data. This is a one-time process, meaning you only need to create the fault volume once for auto-picking faults on that volume. Once you're all set up with the fault volume, turn on the new segment autopick. All faults that were detected in the volume show up here as red lines overlaid on my actual seismic. But these red lines that you see here are not faults that are in my interpretation yet. This is what the fault volume has detected as faults. I must still pick them to include them in the interpretation as actual interpreted fault surfaces. If I click on any one of these red lines, these detected faults, it is picked as a fault segment and added to my active fault. Move to the next inline, detected faults show up, and I can add the next segment to my fault. We also have a feature now that lets you project faults onto unpicked sections. I can turn that on and it gives me a dotted line on where it thinks the active fault should fall on this next section. This feature, by the way, also works when you're picking manually and is not limited to just auto picking. You can go on picking segment by segment, or you can pick the entire fault surface in one click with the surface auto pick. The workflow is the same. Turn on surface auto pick, red lines indicate where we found faults, click on a red line, and we add the entire fault surface here. You can of course edit any of the segments added here to fine tune or correct the fault picks where the algorithm might be doing something that you don't agree with. We also have a bulk picker that can go through your volume and automatically create fault surfaces out of all detected faults with no user input required. The bulk picker outputs what we are calling temporary faults. These are not considered interpreted faults yet. They must go through a step of validation where you look at the fault and then explicitly convert it to an interpreted fault. The objective is to prevent your interpretation from being flooded with faults that you may not actually want in there. When it's done, and I took the liberty of running this beforehand, all temp faults are added to a 3D scene where I can analyze these and make sure I'm happy with them before I convert the ones I like to interpreted faults. You can cut through the clutter really quickly with some interactive tools that let you select multiple faults and delete them from the interpretation or merge them into a single fault. We also have a rows diagram that gives you a better picture of what all your faults are doing. I can view the rows diagram for my temp faults or my actual interpreted faults, so this feature is not limited only to auto-pick faults. The rows diagram is interactive, so let's say I'm only interested in faults that run north-south. I can select that here, and that updates the scene to only show faults in my selection. I can then convert these directly from a rows diagram as well. We've also added a few tools to help make manual picking faster and more efficient. Apart from the project feature that I showed you a moment ago, we've also added several segment editing tools like batch actions for assigning and unassigning fault segments, segment splitting, etc. Let's move on now to enhancements to Geobody interpretation. We introduced Geobodies to GVERSE Geophysics in the 2019.2 version that came out last year. We've added a few things in this release that we hope will help incorporate Geobodies in your seismic interpretations in a more meaningful way. The first of these is the ability to map your Geobodies. I picked this channel as a Geobody and I want to see how the thickness of this channel varies along its length. Just copy it over to a map and that will draw the Geobody on the map with colors representing the thickness of your Geobody. The color bar here lets you see what these colors actually mean, and you can see how the channel thickness varies on your map. There are a few types of data that you can display here. You've got the time structure map of the top surface of the Geobody. The colors now represent the time value. You can also switch to the base surface. We have a couple of type of thicknesses as well. The gross thickness, that's simply the difference between the top and the base surface. The net thickness, this is for when your geobody might have vertical fingers-like features. So instead of just taking the difference of the top and the base, we identify the fingers and then add up the thickness of each finger to get the net thickness. You can also create layers out of these maps and take them to GeoAtlas or Geomodeling and other GeoGraphix apps. You can also convert the top and base surface of the geobody, time structure maps for which we just saw, and convert them to horizons. You can modify these like regular horizons or do horizon math on, or use it in your velocity models or whatever other use case you might have. Finally, one of the most important outputs for any seismic interpretation is attribute maps. The 2019.3 release lets you calculate attributes and create attribute maps from data enclosed within the geobody. From the Attribute and Service Calculator, select your geobody as the window type, choose your attributes, and calculate. This will compute the selected attributes from data enclosed by the geobody and create attribute surfaces for it. You can display these on the map or in 3D. You can also create layers for these if you want to use these attribute maps in other GeoGraphix apps. Apart from these features designed to make geobodies more useful in your interpretations, we've also added seed editing, horizon-bound tracking for geobodies, and the ability to view depth-converted geobodies in our on-the-fly depth view. We are also taking the integration with our geological applications a step further. You can now pick your well tops directly in the geophysics domain. Any changes you make to the tops here are updated directly in the well-based database and are therefore immediately available across all GeoGraphix applications. You can take an existing well pick and adjust it, move it up or down along the well bore, or you can make a new pick for this information top. Add multiple observations as well. We've added the ability to post multiple observation picks along your wells in both the 3D and 2D views. As you would expect, you have full control over which sources to use for your picks. You can also create new tops and fault cuts to pick from within the Geophysics application. As I mentioned earlier, everything is written to the database, so your new tops will also be available in all of the geological applications. We've added a new crossplot tool as well. You can crossplot data from up to 3 volumes. You can crossplot the entire survey or a horizon surface within a geobody. You can also create crossplots at well locations where you can then directly crossplot seismic data with log data at each well location to discover any interesting relationships within those data if they exist. The crossplot comes with a rich annotation toolset, lets you draw lines to indicate trends. You can draw polygons to identify anomalies or other interesting features of the crossplot. And if you see an anomaly on the crossplot and you want to know where in terms of X and Y this anomaly is found, you can simply send it to a map or a 3D view, and those crossplot points will be added to your scene. This is a live link, so as you adjust your polygon, the points are also updated in the 3D scene or the map if that's what you have displayed these on. We are also introducing our first AI-based workflow as part of our base package. It's a facies classification workflow that runs using a self-organizing maps algorithm. It scans the horizon, classifies the wavelets around the horizon surface, and spits out an attribute surface which is color-coded with the different wavelet classes assigned different colors. We've reworked our line balancing workflows. A new interactive line balancing window where you can graphically adjust your lines or auto-calculate the optimal shifts to apply to get the best match between the two lines. We also now store all mistie shifts in a shifts table which you can export and import into, making managing multiple sets of mistie shift values a breeze. For depth conversion, we are adding a seismic velocity-based model which lets you create a velocity model from a seismic velocity text file. So if you want to use velocities from your processor as the velocity model, you can do that now. You can also calibrate this model with existing wells to incorporate information from those wells into your velocity model. For our existing models, you can now use multiple observations in your horizon formation based models. The multiple observation picks will be treated as TD pairs, control points for gridding your velocities. More control points will lead to hopefully more reliable models. We have also made more improvements to our triangulation algorithm for more accurate velocity modeling using triangulation. We are always looking to improve our 3D visualization capability. 2019.3 is no different in that regard. Along with the multiple observation pics that I just showed you, we've added support for viewing attribute surfaces in 3D and also post microseismic data along wellbores. We've also added lighting to the 3D scene. That has a huge impact on visualizing the subtle variations in your surfaces. On the bottom right image in this slide, lighting is turned off. The image to the left of it is the same scene, but with the lighting turned on. And even though the image on the right is giving you the same information, but it's very easy to see and appreciate the relief of this horizon surface with the lighting turned on. For the geobody as well, you can actually see variations in the structure with the lighting turned on, as opposed to it just being a blob when the lights are off. Finally, we have a whole bunch of usability enhancements that will make working in GVERSE Geophysics even easier and more efficient. We are introducing actionable labels for all our warning messages, so you don't say yes to a warning and then immediately regret not knowing what you said yes to. So there's no more yes and no. All button labels are clear in what's going to happen when you press a button. We've redesigned our navigation bar and placed it right there in the scene, so you don't have to find it in the ribbon anymore. We're syncing seismic sections between the 2D and the 3D views, and just so many more little things that I just don't have the time to get into right now. So that's a very quick look at what is part of the new 2019.3 upgrade as far as geophysics is concerned. As you saw, there's a lot of new features here. One thing I'd like to point out before I leave you is that everything that I've talked about today and shown you today, all of this is covered within the base license. So we don't have additional licenses for our synthetic or our automatic falls or well-top editing or anything else. Everything comes as part of the base license. And that brings my presentation to a close. Thank you for listening. If you're a GeoGraphix user, I hope you'll enjoy these new features. If you're not, then I hope you were intrigued enough to give us a try. You can get more information from our website, lmkr.com/geoverse. Thank you for attending.